Hello everyone and welcome to this Microsoft Reactor workshop today. My name is Erika and I am the program manager at microsoftreactor.com. Before we start with this session, I would just like to say a quick word about Microsoft's Code of Conduct. We all come from a different background, but we are all here to learn. So please be welcoming and respectful and be aware of others. Thank you. Today's session is going to be introduced by my dear colleague, Abisola, who I'm adding here now. Hi, Abisola. So
Hi.
if you could just be so kind and introduce the session and our speakers today, and then we can kickstart with this session. Yeah, I leave the word over to you now. Thank you.
All right. Thank you, Erika. Good morning, good afternoon, good evening, depending on what time you are joining us from. My name is Abisola, a Microsoft Learn Student Ambassador from the Obafemi Awolowo University, Ile-Ife, Osun State, Nigeria. So I'll be moderating the session today on data modeling plus exploration of data analysis expression. And we have our guest here, Ahmed Oyelowo. Okay, and she's a Microsoft specialist and also the CEO of Foresight BI. So join me as I welcome Ahmed Oyelowo to the session today. Thank you.
Okay, so thank you very much, Abisola, and good morning, good afternoon, good evening, everyone, and welcome to today's session on data modeling inside Microsoft Power BI. So my name is Ahmed Oyelowo, once again, like Abisola has introduced me, and I'm very glad to be here with you guys today to take you through the journey of data modeling inside of Power BI. So data modeling basically is one of the most important aspects of building solutions inside of Power BI, analytics solution basically. And one of the reasons why it's the most important thing is because data modeling kind of like sets the whole structure for how the output of your analytics is going to come out at the end of the day. So which basically means that if your model is bad, then you should expect that you are going to have a lot of issues with your reporting. So I'm going to be taking you through that journey, and anytime from now, or maybe I should say any moment from now, you can expect that I might probably slow down the pace of my words because I need you guys to understand everything perfectly, because like I mentioned earlier, the entire performance of your solutions depend on how good your data model is. Therefore, we are going to be learning a couple of things about modeling inside Power BI, including how you work with tables. We'll learn a whole lot of concepts in the next 1 hour. So if you look at the word count I have on my screen right now, this basically are some of the things that you will hear me say today, and they also represent the things that you have to have knowledge of when it comes to modeling inside of Power BI. Okay, so you'll be hearing things about dimension. You're going to hear about keys. You are going to hear about one-to-many, normalization, the normalization. Basically, everything that you can see on my screen right now, they all form part of the theory of data modeling that you have to be aware of. Okay, so by my understanding, you already have some backgrounds in Power BI. You have been able to create 1 or 2 reports in Power BI, and you also have experience using Microsoft Power Query. Okay, now when it comes to analytics, when it comes to reporting inside of Power BI, as you may have learned from your introduction classes, a couple of things, a whole lot of things come together. One of those things is basically data prep. So you have to be able to prep your data properly, and that's where your Power Query comes in. And then another thing that also comes into place is data visualization. So visualization basically goes hand in hand with analysis. Okay, so if you don't prepare your data very well, your data is not properly clean, you might really not be able to do proper reporting and analysis. At the same time, if you don't do number 3 item properly, which is what we are here for today, data modeling, then the entire process is going to be in chaos. All right, so join me on this journey as I take you through the world of data modeling inside of Microsoft Power BI. All right. So basically have to start with some, theory in my slides to get us going. So when we talk about data modeling inside of Power BI, it comes with a lot of benefits. But before I talk about the benefits of data modeling, I would like to take us through a little journey of what data is about, how we capture data, and then what brings about data modeling in the first place. Okay. Now, first of all, you should be aware that there are typically several methods for storing our data. There are many methods for storing data. You can store data as tables. You can store data in documents. You can also store data in different, maybe in binaries, for example. So there are always typically different methods for storing our data. But one of the most popular methods for storing data is as tables. Okay. And tools like Power BI works with data that are stored in tables. Now, what exactly is a table? A table is simply when you have a collection of data that is stored inside rows and columns. So eventually, you are going to have several rows like this for your data, and you also have several columns like this for your data, which gives us something that we refer to as tables or tabula, like this, right? Now, when it comes to storing data in tables, there are a couple of things that may come up. One of those things that may come up is something that we refer to as redundant information, right? So it's possible for you to have redundant information on your tables when you store them. And what do I mean by redundant information on your tables? Let's assume that you are thinking about an educational setting, like a school setting, for example, where you have student records. You know that in school, the first thing that you want to do when you register in your school basically is for you to provide all your information, right? Where you have things like you have something like a matric number. So you have a matric number. Of course, you need to have a name. You probably will provide some other information like maybe your date of birth and so many other things that we typically classify as biodata. I'm sure most of you remember that biodata. Now, that's your biodata is something that typically is reserved for you alone. Now, if you check in your school records, only one single person can have a particular matric number, which means that if you see one matric number, that matric number is going to be assigned to only one single person. Now, even if you have like 5 different Ahmed Oyelowos in a particular school, trust me, they are all going to have different matric numbers. Okay, therefore, in a school setting, you will have some kind of data set that is referred to as your students' biodata records, whereby every single person in the school is supposed to have a record or a row that provides the biodata of that particular person, right? So, for example, if this is row 1, row 2, row 3, row 4, and row 5, this will represent records for 5 different persons, right? And it is about biodata record, then it means that every information about that person can be found on this table. Okay, now for every class you take, if you are familiar with the university setting, then you know that at least in Nigeria anyway, for most university settings in Nigeria, there is something that we usually call attendance. So when a lecturer comes in to teach, the lecturer is going to say that I'm going to take your attendance. Guess what the lecturer is going to take in attendance? So when the lecturer wants to take attendance, they will probably just ask for maybe just one single information alone for every single student. So you only have to enter your matric number as attendance. Okay, I'm sure maybe there are probably some cases where you also need to put in your name, but typically the most important thing for you to enter is your matric number. Now imagine a situation whereby every single time a lecturer comes into your class and the lecturer asks for you to take your attendance, and you always every single time need to provide all the information that you already have on your biodata records. So lecturer one comes into class today and wants to take attendance, and then you need to provide your matric number, right? So you provide your matric numbers, everybody provide matric numbers, and then they also provide their names, then they also provide their date of birth, and then they also provide maybe their nationality, their state of origin, all those information that we typically provide in our biodata information. So imagine if you always need to provide all of this set of information every single time you want to take attendance, given that you are most likely going to take attendance every single day. You agree with me that once the school collects your biodata information the very first time, they don't always need you to repeat all the details every single time you need to provide your records. Every single time, like when you want to write your exams, you need to get your answer papers. You don't have to provide all the information about yourself every single time. You only need to provide your matric number. All right. Now, the reason why that can work is because the very first time the school takes your information in that biodata records, they already have every detail that they need fixed somewhere. Therefore, all your other activities where they need to identify you will no longer have to request that you provide all those full details again. All right, that's example number one for you. Okay, now all those other details that you don't have to provide every single time is what we refer to as redundant information. That information is already somewhere, whereby if I have your matric number and I get into your biodata records, I can pull out every other information that I need, right? Therefore, for all my continuing activities, I would only have to request for your matric number. If I start to request for other details, your nationality, your date of birth, and all those other things, that means I'm asking you for redundant information because that information is already there in your biodata record. Example number one. Example number two. I'm very sure that most of us have bank accounts. Okay, so you have bank accounts. Now, when you go to bank for the very first time, to go to a bank for the very first time to open an account, you are going to collect, a bank account opening form where you furnish several details of information, right? In your bank account opening form, you'll be providing your name, you'll be providing maybe even your next of kin, you're providing your date of birth, you provide your phone number, you provide your address, and you provide so many other details like that. And then at the end of the day, the bank is going to issue you with an account number. Okay? Now, just like the situation of the education sector, whereby even when you have 5 different Ahmed Oyelowos in a particular bank, they are all going to have different account numbers, isn't it? Okay. Now, at the end of the day, you've got your account number, you've provided your details. Just imagine that every single time you need to make a deposit in your bank account and you get into the bank to fill a deposit teller slip. Okay. Imagine the bank always asks you to provide your next of kin, your date of birth, your phone number, your address, and even your name and every other thing every single time you want to do a transaction. Maybe you want to pay or maybe you want to withdraw cash. The bank will never ask you for that because the moment you open your account, the bank has already created some data records for all their customers, and this data record for all their customers have been stored into tables whereby every single customer will have their own records, right? Containing their account numbers, their names, their date of birth, and all other information. Therefore, every other bank activities that need to take place that the customers need to engage in, they don't have to provide redundant information. They only provide the key information, right? And the key information is always, in terms of banking, it's going to be your account number. In terms of education, it's going to be your what? Your matric number. And if you think about maybe businesses, for example, then you can start thinking about something like a transaction ID, some invoice numbers, some order IDs, and things like that. All right. Now we have an understanding of what redundant information is. We know that as much as we capture data, as much as we record transactions, as much as we record business activities, not all of those business activities data need to be recorded repeatedly. Some of them have to be stored somewhere permanently because repeating them becomes redundant, right? As long as they are known values, right? As long as they are things that are already known and they are fixed, then we can store them somewhere and continue business without having to repeat those information again, because repeating them constitutes redundancy. Okay, now that idea of having to record data without giving the full details of records, because you have some of those records somewhere else, is what birthed the idea of data modeling, which we are going to be looking at right now. Okay, so now what are some of the benefits of keeping a data model like that, whereby you store some known values somewhere? They are fixed: biodata, customers records, product details, and so on and so forth. And then you continue to enter your business records, your day-to-day business activities. You continue to get all those records. You continue to capture all those data without entering the redundant ones. Some of the benefits that serves you for doing this is that it will give you more accurate reports. It's going to enable you to explore your data much faster, because you don't technically have to record every single thing every single time. You have fractions of everything in different places. Then it's going to enable you to perform something simpler: aggregations, right? You know what aggregations are? Aggregations are basically when you summarize data, because at the end of the day, data analysis is all about data summarization. You always have to summarize, okay? And then it becomes easier actually for you to maintain your data as well. All right. Now, in terms of modeling, there are different things that, in terms of tables, basically, because when we talk about business records now, for example, I already explained the fact that you can have one biodata information somewhere that is fixed, and then you can continue to record your business activities in another place like that. Okay, that means you are going to be keeping different sets of tables. That means everything is typically not together. You have things, disjointed in different places, because some of those things represent what? Again, they represent redundant information that you cannot continue to repeat every time you have a new business activity, or every time you have a new activity, depending on the sector. All right. Now that will basically give us two different types of data tables that will always store. Okay, so depending on the function of your tables now. So if you think about the things I've mentioned now, you will see that I've already mentioned that some tables are stored for keeping, let's call it permanent data. Okay, so permanent, let's just use that word right now. So some tables are stored for keeping permanent data. Some tables are stored for keeping continuous activity. Okay. So if we refer back to our two examples of education sector and finance sector, the school and the bank. In the school, permanent data, students' biodata. Continuous data, attendance records every time you go to a class. Okay. In the banking sector, permanent data, the account opening package form that you fill that provides the details of the customer, right? That's the permanent data. Continuous activity, your banking transactions, transfers, withdrawals, doing all those other banking transactions, like maybe you want to pay for DSTV, you want to pay for GoTV, and those other things. Those ones represent continuous activity. Therefore, there will always be two types of data tables stored for business records: the one that is permanent and the one that is continuous. And this typically will lead us to mentioning the names for these two types of tables or this type of data records that we have, the one that is permanent is what we usually refer to as dimensions, and the one that is continuous is what's referred to as fact. So at the end of the day, if you check into your business database, if you check into your organization's database, you are going to see that there are different tables scattered around, right? Now, those different tables will be classified either as dimensions or as facts. And what does it mean to classify them as dimension or facts? If it is a dimension, it means it stores some permanent records. If it is a fact, it means it stores continuous business activity, if it's a business, right? Okay. So having several different dimensions and several different fact tables will always lead us to have typically two types of popular models that are called star schema and another one that is referred to as snowflake schema. Okay, snowflake schema. So we can basically for now ignore the snowflake and let's just focus on a star schema. So a star schema is the kind of model you have when after putting together all the different tables that you have, you realize that you have the different dimension tables having a relationship with your fact table, and I'm going to talk about that in a bit. But before I talk about it, let me show you some data set that I have on Excel. So this is one Excel data set for a sales data, and you see that what we have on this sales data, I will just quickly run you through the different sections of things that we have. So we have an order ID. So this is basically like a superstore, like a supermarket, like we usually call it here in Nigeria. So this is like a supermarket technically, whereby, you know, for every single transaction, you know, you have to enter an identification for that transaction. Okay. So that's what we refer to as order ID right here. And then the business also captures details about the dates, right? So every transaction that happens, you must record the date for that particular transaction. And then because they do deliveries as well, they also record the dates when the delivery is going out, and then they also record the type of shipment that they use for the delivery, right? So is it going to be on the same day? Is it going to be maybe a little bit delayed? Maybe you can refer to one that is going to be delayed as maybe standard class, or maybe first class, and so on and so forth. So you have ship modes, and then they have the records of the customers as well. So every customer has an identification, just in case you have two Ahmed Oyelowos, right? So how do you differentiate them? You can only differentiate them by assigning different IDs to different customers. Just like you will have different matric numbers for different people, and you will have different account numbers for different people, just in case there won't be any kind of mix-up, right? So the customer details is there. You have their IDs, you have their names, and you have their grouping. So how the customers have been grouped into some kinds of grouping that we have here. We have consumers, customers. Some customers are referred to as consumer customers, more like retail. Some are referred to as corporate customers, more like organizations and companies. And then some are home office, just somewhere in between retail, in between consumer and corporate. And then the data also keeps information about the sales representative. That's people that are like the marketers in the organization that are bringing people to come and buy. Okay. And those sales reps basically belong to different teams. Okay. You can see that as belonging to different departments in the marketing team, right? So you have the ID of the sales representative, you have the name of the sales rep, you have the team, and you have the manager of that team as well. That's part of the data that they collect. So every time somebody is coming to buy, every time there's going to be a transaction, the records that the business needs for analysis that they need to capture is, okay, so this transaction, somebody is coming to buy, we provide another ID for that transaction. We record the date for the transaction. We record when we are going to ship it for delivery. We record what type of delivery mode are we going to use. And then we record in the ID of the customer, the name of the customer, and the group that the customer belongs to. Then we're also recording, so how did this customer come, right? Who is the marketer that provided a link to the customer to come to us, right? That's the sales rep ID, the name of the sales rep, which team does the sales rep belong to, and who is the sales rep manager, right? And then we now go on to record. So where exactly are we delivering the product to in terms of a location? Which city is that? Which state is that? What's the postal code and what is the region? Those are part of the things we need to be able to analyze our sales information properly. So we are recording all this plenty information we are gathering. We need them for analysis, okay? And then obviously we have to capture the product. So what's the customer buying? And that particular product the customer is buying, is it a furniture in terms of category? Does it categorize as furniture? Does it categorize as technology? Does it categorize as office supplies, at least for the business that we deal in? And then what's the subcategory for that? What is the name of the product itself? And then obviously we must also capture the amount that the customer is buying. How many quantity of products is the customer buying? Are we giving discounts? And what profit are we making? Now, technically, we need all this information is what we need for carrying out the analysis for our business. So we have already created a standard that every time a customer is coming to buy, we need all this information so that when we want to analyze, we can basically look at our business in different perspectives, okay? What you probably have not realized is that when you start to capture all of this information for every single transaction, every time a customer comes to buy, you record all these things. In here lies some redundant information, okay? Therefore, you have to do something in data modeling that we refer to as normalization. Normalization is now the process of going from, keeping all this information together like this with redundant info and breaking them up into different entities, right? Now, if you start to check properly, we are going to identify some redundant info. So I'll just quickly show you all of this redundant information right now. Now, if you look at these customer details that we have here, you can see this like your student records or the customer records in the bank. Once you have a customer's ID recorded, there is no point in recording the name and the segment, that's the grouping of the customer for every single transaction anymore, because these two are now going to be regarded as redundant. Okay, all that you are required to do is have a list somewhere, like the student biodata records, have that list somewhere where you basically have stored all your customers' information, like student biodata. Therefore, for every time you want to take attendance, only record what? Your matric number. All your other details, when I get to your student biodata records, I will find them there. Okay, same thing applies to this business here. For these customers, all you need to record when a customer is coming to buy is the customer's ID. You see the name and the segments, they are going to be redundant because these are fixed data, right? Once there's a customer ID, that customer ID will forever be for that particular customer, right? And most likely that customer belongs to a group already, okay? So in this case now, some of the redundant data set that we have here are customer name and segment, because we can just take all our customers and create a records for them somewhere, create a different table for customers in a different place, so that anytime we need more information from there, we can easily go there to retrieve all that information. Okay, now here we have sales representative ID, right? There's a sales rep ID right here. There's the name of the sales representative, there's the team, and there is the manager. The same thing applies. You see the sales rep name, the team, and the manager for that sales rep. These are all redundant information because we can basically just capture all of these things somewhere and keep them somewhere as our sales representative data. Okay, if you think about the education sector, for example, you will have your student bio data. You probably most likely will also have maybe the subjects that are being offered in the school, right? So there are always different kinds of entities that have permanent information like that you can just keep separately instead of recording every single thing for all your business data, right? So redundant info here, sales rep, sales team, and the manager, they are all redundant. Now, if we keep on here, we'll see that we also have location information as well. So for our location information, guess what? After recording the location ID, you don't need to provide the city. You don't need to provide the state. You don't need to provide the postal code and the region, because from looking at the location ID, you most likely are going to know which city that belongs to, right? So if you are living in Lagos, for example, so if I mention Oshodi, for example, there is no point in recording Oshodi and still recording Lagos State, and there is no point in recording something like maybe Abeokuta and still recording Ogun State for every single transaction. Why? Because those are known values. You can just store your location details that are permanent somewhere on a different table. So when a customer is coming to buy from a particular location, just identify the key thing about that location and record it and forget about every other thing, because it will introduce redundancy into your records, right? So these are some other redundant info here: city, state, postal code, and region. And when you go to products, you will find that there are also redundant information on products as well, like category, subcategory, product name, and so on and so forth, right? So when you have data like this with redundant information, everything packed together, you have a denormalized data set, right? Now, to normalize it, you typically have to separate the entities that are permanent, that have permanent information. You have to separate them and create something that is called a normalized data set, whereby if I go to my other Excel spreadsheets here, normalized data, you are going to see that instead of having every single details in one permanent Excel worksheet, we have broken them down into different types of tables. So on one table, I have my sales records. On another table, I have my customers. On another table, I have my sales representatives. On a different table, I have my locations. On a different table, I have my products, and so on and so forth. Okay. Now, having broken down all my data sets now into all of these different entities, that can introduce some problems into my reporting. Okay, it can introduce some problems if we don't do certain things. All right. Now, I'll show you those kind of problems, and then from there we can, take the lecture further into the other things that you need to know about data modeling instead of Power BI. Okay. Now, let's assume that we have been provided with these data sets normalized like this. That means everything is not together. You have different tables in different places, and you're supposed to analyze the whole data set as one single data set for your analysis, which you will always find when you are connected to a relational database. So when your data is coming from a relational database, like Azure SQL, for example, like SQL Server, like MySQL, like Sybase, like Oracle database, and places like that, okay? PostgreSQL, if those are your data sources, you can expect that once you connect your Power BI to those data sources, you won't find all the data together in one place, right? You are probably required to provide an analysis about the sales from your different regions. What you are going to find out is you will see your sales on a different table and you are not going to see regions there, right? So if you see sales on a table and the regions are not there, then how do you calculate the total sales for every region? That becomes a problem because all your data are scattered in different places, and that's where your modeling skills now needs to be harnessed. Okay, so I'm going to bring in this data set into my Power BI now. This is my normalized data set where everything is scattered, and I'll show you how you now build a Power BI data model. Okay, so if I go to my Power BI desktop, I think I have one open here. So this is my Power BI desktop. I want to get data from Excel. Okay, good enough. You guys know Power Query already. So I'm collecting data from this Superstore normalized, and I want to click open to connect to my Power Query. Okay, so these are all the tables that we saw. I need all of them. The customers, the locations, the products, the sales, and the sales representatives. I need them all. I probably will need to perform some data cleaning inside, which is very good for us. So now I'm going to click on transform data. And I will just basically look through each of those tables to confirm that they are all looking good and clean. So for example, if you look at my sales representatives, you will see that, I have some really empty rows at the bottom right here of my sales reps table. So what I will do is I will click on one of these columns and I'm going to highlight all the columns with Control A to highlight all of them. Then, because I want to remove some rows, Power Query is really easy to use. All I need to do is what? Go right here on my home and go here to where I see remove rows. I'm going to use that drop down to say what I want to remove the blank rows, right? So remove blank rows and those empty rows are gone. Okay, so this is looking good. Now let me check my sales table. So my sales table, just a quick glance through to ensure that it all looks good. I think everything is fine. Then I go to my products table, and now if I check through my product table, I see that it is not really fine because the row 1 on my products table is supposed to be my header row, which I don't have now. So quick Power Query transformation. Go to transform in Power Query and use first row as headers. Okay. Then I go into my locations table, and again a quick glance through to check if my location table looks good, and I think that's fine as well. Then I go into my customers table, and I have the same problem with my header. So my row 1 is supposed to serve as my header, so I'll just use first row as headers. Okay. Now I think everything is fine. If everything is not fine, you know what we'll do, right? We'll have to come back right here into Power Query. So let me go to home and close and apply. So now I've loaded the data basically, or I'm loading the data, every single part in different places, disjointed. And then as the data analyst of the business, I have a requirement to provide some analysis. Maybe, for example, the business wants to see the sales by region. They want to see how the different regions are performing, right? Maybe they also want to see which manager, which sales team manager has the highest sales, right? Let's work with those two examples for now. So let me go to my whiteboard and just note down those requirements. So the business wants to see two things for now, very quickly, urgent. This is urgent, right? So the business wants to see the sales by region, and the business also wants to see the sales by manager. Okay, they want to see which manager is bringing in the highest number of sales, for example. So the business wants to see these two things. Now, when I go into my data and I go to my sales table right here, let's say I go to my data view, right? That's where I can see the table itself. So if I go to my sales data on my data view, when I start to check through each column, eventually I'm going to see my sales column. So I can sum up all the sales, but then I want to sum up all the sales of each manager. The problem is, where are the managers and how do I sum up the sales for each manager? And you realize that, man, so I've normalized my data sets and I've taken away the information where I have my manager. Okay, but then there's a solution, because if I need to see the managers, all I need to do is what? Go to a different table. So I have to go to my sales representatives table, and that's where I have my sales team managers. And that introduces a problem, because how do I now tie these sales right here on this sales table For example, if we pick one single sales, this 1044.63 sales, which manager does that value belong to? Okay, I know I have my managers on a different table right here on my sales reps. I have about how many managers? Maybe 4 or 5. 1, 2, 3, 4. I have 5 managers. Okay, and the question now is this: this first sales record that I have, technically all of the sales record, how do I tie them to each of those 5 managers, given that the manager's information is on a different table and my sales info is also on another table? How do I tie them back? Okay, so how you tie them back is where another thing comes into modeling that we call relationships. Okay, so for example, when you take attendance in class and you only record your matric number 1001, that's your matric number, how do we eventually find out who is 1001? The only way to find out who is 1001 is we have to go into your student biodata records, right? Go into your student biodata records and look for that person that has 1001. Then we can get the person's name, we can get the person's date of birth, we can get the person's address, and every information that we need about that person. Once we have this 1001 matric number, we can retrieve all those other information from the other table. And guess what? We started data modeling right from nursery 1 or nursery 2. Okay, you might not believe it, but we started data modeling right from there. We started data modeling the moment we started something like this. Okay, the moment we started something like this, if you remember very well, where you have to do this mapping this way, map all of this information together, that's exactly when we learned how to do data modeling. Because what we are simply saying now is that you have two separate kind of records. Say, for example, you have your 1, 6, 9, 8, for example, and then you have another record here that says 9, 6, 1, 8, like this. But then this second set of records provides some more details. So maybe 9 is Ahmed, and 6 is Ola, and 1 is what? 1 is give me one name now. 1 is David, and maybe 8 is Oyelowo, for example. Okay, now you have one record of data on a different place right here, and somebody is asking you, so who is number 1? What do you do? Who is number 1? You simply kind of like try to tie number 1 here, and you see that, oh, number 1 is David. So you come back here and say, hey, number 1 is David. Who is number 6? You quickly do this. Okay, number 6, this is it. Okay, number 6 is Ola, right? Who is number 9? You do this. Okay, number 9 is Ahmed, and so on and so forth. So at the end of the day, you have two different records sitting separately, right? But then you need information from the other side to come in to one of those places. You need to do some kind of mapping. That mapping that you are doing, I said, is called relationships, right? That's what a relationship is. So if you look at your Power BI now, you want to do that sales by region, but here we have sales, we don't have region over there. We need to be able to tie the two together so we can, you know, map each of these sales to each of those regions. The only way we'll be able to do that is if we look at everything we have on this our sales table now. Which one of them do you think can help us to identify region? If you check through, can I identify the regions by the order ID? No. By the order dates? No. By the ship mode? No. By this? No. Guess what? By this location ID, I will be able to identify the regions because every region belongs to a location, right? Just like for your student records, by the customer, by the matric number, student matric number, you can identify all the other information. For customer records, by the customer's ID, you can identify all the other information like the name, the address of the customer, the group of the customer. From the product ID, you can get all the information about products like the product's name, the product category. Even if there is a price for that product, you get the price of the product, right? And so on and so forth like that. That's where relationships come in. And if you look at your Power BI desktop, you are going to see that there are three views, right? The first view where you build your reports, the second view where you see your data, and then the third view where the relationships are mapped out. Okay. Eventually, once you have your tables scattered all over the place like that, you should expect to have all of these things, all different tables scattered around. You have products, you have locations, you have customers, you have sales. Which other one did we have? We have sales representatives. Okay. So the idea is this now. When you have all of the different tables scattered like this, the main business activity. So if we take us back to the beginning of the session, we said every single table will represent two kinds of things. Okay. Every single table represents two kinds of things. In simple English, the two things I said are permanent records, while the other one I said are continuous records. Okay, so if we look at all of these 5 tables that we have now, and we try to identify which of them actually has continuous records, you will see that it is the sales data, because the sales is the business activity, is the one that generates business continuously. Okay. The locations table, on the other hand, stores permanent data, right? The locations are locations. You don't have new locations coming up every day. Sales reps are sales reps. You don't have new sales reps coming up every day. Your products are your products. You don't have new business lines or products every day. It can happen once in a while. And then your customers, yeah, your customers can grow technically, but then your customers are also your customers, right? You just keep on adding more customers, but it is not the defining business activity. So it's not exactly a continuous business activity. So the only business continuous activity that we have right here is the sales table, which is going to represent, again, our fact table. And every other one that you have here are dimensions. Okay. So what you always have to do is this. The sales table will always keep the sales records and only some key elements of the dimensions, right? Because we always eliminate redundant information from the sales table. And the sales table, again, is your fact table. Remember, fact table, dimension table, they represent facts, represent continuous activity, dimensions represent permanent activity. Okay. Now, at the end of the day, once you have recorded your sales, which represents your continuous activities, you don't want to record redundant information there. Therefore, instead of putting the details of the customers, you only put the customer's ID instead of all details of the customer, because you don't want to waste time, you don't want to waste space, right? You don't want to enter redundant information. The customer is coming to buy, you only record the ID. You don't record the name, you don't record the address, you don't record the phone number, because you know that what? If you need the name, address, phone numbers, you can easily pick that up from the customer's bio data, which is your customer's dimension. Okay. Now, when you have something like that at the end of the day, you have broken your data into different tables, you have to connect them back together. Okay. Now, in connecting them back together, remember, you only recorded the key thing on the fact table. That key thing you have on the fact table is luckily for you also available on your dimension table. So you will have to kind of like relate the two tables together. So as we have customers ID here, you have sales here. Sometimes you might be lucky that Power BI will just automatically detect those relationships for you. And that's where you see these lines that you have connecting different tables together. Now, where Power BI has not detected relationships, what you have to do is to manually create the relationships. And how you manually create it is really easy. All you have to do is this. If you look at the customers table and the sales table, what we need to use to connect the two of them together to create that relationship is the customer's ID. Okay, so if I want to know information about a customer, I will just look at the customer ID and I'll go to the customers table, check the customer's ID. Remember that mapping 1, 2, 3, 4, 5, 6, 1, 2, 5, 5, 6. You do that mapping right there, right? So the customer's ID is what you use to do your mapping. That's what makes the customer ID to be the key thing in your data. Okay, so from the customers table to the sales table, you want to do a mapping that is based on the customer's ID. So just drag customer ID from that side or from any of the two sides and map it to the customer ID at the other side. Okay. All right. We have some issues, many to many. So data is probably not clean. And like I said, if data is not clean enough, we have to go back to the what? We need to go back to our table. So let's go back to Power Query, transform data. And let's look at our customers table, right? So the thing about dimensions is, they always have to be unique. So dimensions always have to be unique. So customer table is probably not clean enough because we have an empty row there. So just bad data. So let me highlight, remove rows, remove blank rows. I'll just do the same for all the other tables as well. So location highlights, I think they have some empty rows beneath them. Remove blank rows. Products, highlights, remove rows, remove blank rows. I did for this already, so close and apply. Okay, so let's try that again. Customer ID to customer ID works. Then connecting the location to the sales table, location ID has to be what we use to map to location ID. So just drag and drop like that, and you have your relationships perfectly created, right? Now, once you have this all perfectly created like this, then it becomes easy for us to answer the two questions. So the two questions that we wanted to answer are our sales by region and our sales by manager. Now see what's going to happen. So if I use a simple bar chart here, I know that my sales is on my sales table. So I could go to my sales table right here and tick on my sales. But I know my region is not here. So I don't have regions here. If I want to get to regions, I need to go to my locations table and pick region. So once I do this, I can see my sales by region easily. Guess what? That only works because I have a relationship between the table that has sales and the table that has locations. So if I right click now on this relationship line and I break it, give it a breakfast. So if I break that relationship right now, if you go back to check your report, you will see that this doesn't work because I cannot differentiate the sales between each of these things anymore. And then how can you differentiate the sales? If you go to your data once again and you look at the sales for the first person as an example, 1044.63, this sales is for who? This sales is coming from which region? When you check through your table, you can't see the region that the sales is coming from. It's not there. Therefore, when you check your report, you can't differentiate the sales for each of the regions, and that's why you have the sales being the same thing all over. The only way you'll be able to differentiate is when you map the table that has your regions to the table that has your sales. Okay, I'll just show you one more time. The only way you'll be able to see it is when you go back to nursery 1 and you do a mapping. Right? When you map the sales table to your location table, that's the only way you'll be able to find the correct answers. That's the only way you'll be able to know that 1 represents David, 6 represents Ola, 9 represents Ahmed, Okay, that's the only way you will find out that these sales of 1044 blah 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 is for a particular region. The only way you'll be able to know which region that sales is for is when you pick this location ID right here, 84057 OREM, and you go to check it on your locations table. It's going to be somewhere here. Just look for that 8047 blah 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 OREM. When you find it here, then you will know which region that sales is coming from. And how you do that simply is to draw that your line between the location ID on the first side to the location ID on the other side. Once you have that done, you always check your reports. Everything will always work fine. All right? I've got 4 more minutes. Okay, so what else should we know about data modeling in Power BI? So now we've learned a couple of things. We've learned that you don't get to see your data in one single large table every time. Many times there are redundant columns in that your data. You don't want to keep those redundant columns. So what you do is you split your tables into 2 types of tables. A fact table where you can continue to record business data, but in that fact table, you're only recording key information. Okay, and then that's your fact table, one side. I mean, don't let me call it one side, let me just call it a side. Okay, the other side, you have kept your dimensions there. Your dimensions are your fixed information. We always refer to them as entities. In terms of businesses, there are always some classic entities in businesses. Classic entities: customers, products, locations. They're always classic. So for most business information, when you check through the data set, you can easily go and identify all the things about the customers and remove the redundant ones and keep only the key thing. When you check the data, you always see things about the product. You always see things about locations. Not everything is important for you to record for every transaction. Always take out what is redundant, right? So we've learned facts, we've learned dimension, and we've also learned that without creating a relationship between fact and dimensions, you will not be able to do your reporting properly, right? Now, when you now create your relationships like this, as we have seen, if you notice, you would have seen that there is this notation that you can find on the end of every single relationship. As you can see, all my dimensions are connected to my fact table, but when you check, you see that there is a 1 sign here and there is a star sign here. All right. Now, to see what's really happening in any of these relationships, what you can do is to double click on the line. When you double click on the line, it's going to open up this dialog box for you where you can see more details about your relationships. And here you will see these 2 things called cardinality and cross filter direction. What cardinality basically means is based on these 2 relationships that we are looking at right now between the customers and the sales. You know, they are related by the customer ID column. The student biodata records, for example, your information will only appear once on that student biodata records, but you are going to take attendance many times. Okay, so when they want to do the mapping back, you see that if they check your student biodata records, they will only see your record once there, right? That's the permanent data dimension. But the main business activities, every day you go to the attendance, you would have taken several attendances and you would have recorded your matric number several times. That means many times. So when we are going to check from the other side, we only have to check 1 record on your biodata record to see your details. So in terms of how the tables keep the key information, that's what we refer to as the cardinality of the relationship. There is always, not always, but there are many times you will find a 1 side and a many side. The 1 side is always the dimension whereby every information there is unique, while the many side is always the activity side because 1 customer will buy many times. Several customers will buy many products. Several people are going to buy from the same city. But then, if we're talking about the customers table alone, every customer appears once, 1. But 1 customer will buy many times, many on the sales side. Every product will appear only once on the products table because each product has a category, subcategory, and so on and so forth. But many customers will buy the same product many times. On the sales table, products will appear many times. Locations, we only have locations, permanent tables. Oshodi is in Lagos, Abeokuta is in Ogun State. We store all that information once. You don't store Oshodi 2 times in your locations table. You only store Oshodi once in your locations table, right? But then several customers will come to buy from Oshodi in the sales data, many, right? The same thing goes for sales reps. You only have about how many marketers, how many staff do you have? You have a fixed number of staff, but those fixed number of staff are going to bring in many customers to come to buy, to come to do sales transactions, many. So in terms of cardinality, what cardinality simply means is how the two columns are related together. So sales rep on the sales table, I can see it many times, but sales reps on the sales rep table, it only appear once because it's like a master data. That's when you have cardinality, and there are several of them. There's many to one, there's one to one, there's one to many, and there's many to many as well, right? So when we want to start to look at DAX in our class tomorrow, we're going to expand more on cardinality and cross-filter direction because they actually also affect how you write DAX as well, right? So I hope you've been able to learn a lot in this short while. So I'm just going to stop sharing my screen and hope that we'll probably have some questions that I can respond to. So questions from anyone?
Hi, Ahmed.
Hi, Erica.
Yes, I don't know if you've been able to follow the chat, but I think the chat speaks for itself about the session today. Everybody is loving it. Everybody was saying that this is fantastic, one of the best sessions they have heard or seen. So thank you for that. So yeah, guys, if you're watching and have questions now to Ahmed, this is the time to ask them. Here is one question. Let me just put it up here from Grace. What if the data is not about sales, in which case there is no numeric column? How do we identify fact and dimension tables?
Okay, that's from Grace, and that's an excellent question because it's not every time that you get to have numeric data sets. So, for example, when you look at HR data, for example, so HR data usually does not contain numeric columns. It's mostly about qualitative data. Therefore, except there has to be some kind of repetitions. So, for example, I'll give you one very tiny example right now. So, if you have, let's just use employees meetings, right? So every time you go into a meeting, for example, you sign for the meeting, right? And what do you sign for? You sign against your staff ID. Let's say you have staff ID and you also have staff name, okay? Just as an example, right? So you have staff ID and you have staff name. You probably, maybe every other information about staff may come in, maybe the location of the staff and so on and so forth. Now, at the end of the day, you end up having several data set about different meetings. So let's say you do meetings every week and then they capture information about your meeting, right? You agree that there is no, what's it called? There is no numeric information right there, okay? Now, when they want to capture the meeting info, maybe at the end of the day, okay, sorry, I'm not sharing my screen, right? So, sorry, let me just quickly share.
I'm not worried. Always. And yeah, well, I believe you can just wrap that up in like a minute
All right.
because of time. Honestly, if we give 3 hours, we cannot exhaust because of the volume of insights we've been sharing and how engaging the session is. So thank God we have tomorrow to still, do one of the things again. Okay, so please proceed. Just use 1 minute to round up.
All right, so I'll just use 1 minute to round this up. So, like I was saying, so you have this meetings data that you always capture at the end of every meeting, right? People just need to enter their staff ID and maybe their staff names. In fact, they probably don't need to enter the staff name, just the staff IDs alone, and then they sign, right? So enter your staff ID and sign. At the end of the day, you might be required to pull out information about, where are people coming from? The people that come to this meeting, where are they from? How many people came from social department? How many people came from social department, right? Now, you don't need to keep on recording your departments every time that you come for a meeting, right? Because you can have all those information on a different table that has your staff info. So on that table, you already have everybody's staff ID, you have their department, you have their location, and so on and so forth, right? So once you are able to identify which elements you can do without because of a factor. So you already have a factor, staff ID. Now, if you have a staff ID, you don't need to record location, departments, and all other information every single time. Therefore, you will have a dimension table for all those information, right? So regardless of whether it's numeric or it's not numeric, that doesn't stop you from, having different dimension tables.
Thank you very much, Ahmed. I'm trying to also, project it well. To be honest, I have been busy sharing these insights that you are sharing, taking it from you and literally putting it out there so that people can indeed you're a teacher. And there's no way we can, pay or reward you for this that you've done and that you continue to do, even for students. I mean, for everyone participating in 30 days of learning. You can actually connect with Ahmed on Twitter. I've made a lot of tweets, hashtag him, at him, and you can also see the link to follow him on Twitter in the comment section. Abisola, just one word from you. How would you describe the session today?
The session is actually fantastic. Like, it was all premium content. Like, I don't know how to describe it. I've learned a lot from the session. Thank you, Ahmed.
Amazing. I mean, same here. It's been premium, lot of feedback, and thank you guys. Please keep sharing and tweeting on Twitter as to what you're learning, and we continue tomorrow. Tomorrow we dive into DAX, and I want you to sign up for that session as well on the Microsoft Reactor meetup group. We're going to share the link. I'm going to try to pull up the link shortly, just so that I can share that with you, and also feel free to follow the data set that was shared. We're going to upload it on our regular GitHub channel and also add it to the landing page document. You see the link for today's session. In the next 2 hours, the link will be up. And from there, you can actually link back to all this material that we shared. And you can follow to replicate all the things you have talked about in this session. Well, thank you very much. And to Erica, our producer at the back end, thank you for making it so seamless and easy for people to follow through. And for everyone that tuned in, up to now, and I want to say thank you. Thank you, Abisola, for really moderating this session. It's awesome. And till we meet tomorrow, bye for now. Thanks, everyone.
Thank you.